This is 2.6.15. So we're supposed to be making a lot of components. They're supposed to be independent of each other. They have a mean, they have a standard deviation. So now we want to know, well, what would happen if we took 5 components and took the average? And I could do this lots of times. Like I could take 5 components, take the average, take 5 components, take the average. So now of that, if I do that, take the average 5 times, if I do that many, many times, I would get a data set. So now let's find the mean and standard deviation of that data set of averages. So what we're looking for is we'll have a new random variable, which we'll call x bar, and that will just be equal to x1 plus x2 plus x3 plus x4 plus x5 over 5. So our expected value of that, well, we just take the expected value of this. So expected value of, again, x1 plus x2 plus dot 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 plus x5 over 5. Now that dividing everything by 5 can just come out. So we have 1 over 5 times the expected value of x1 plus x2 plus all the way up to x5. So this will be 1/5 times, let's see, and then let's add up each expected value. Now each expected value should be equal to that mean of 65.9. So we'll do 65.9 plus 65.9. We'll do that 5 times. So we get 1/5 times 5 times 65.9, which leads us back to 65.9. Now you might remember in our book there is a theorem that says, guess what? Every single time we take the expected value, we do averages, this is going to happen. The theorem says the expected value of x bar is always equal to our given mu, so it's just 65.9. Now for your variance of x bar, because we always have to do variance before we can do standard deviation, that is equal to the variance of this, again, x1 plus dot 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 all the way up to x5 over 5. Now when you want to pull a number out of the variance, that's multiplying or dividing your variables, you have to pull it out squared. So we 1 over 5 squared times the variance of this x1 plus all the way up to x to the 5. And you can just add the individual variances. So this will be 1 over 5 squared times, now these are only standard deviations here, so we'll have to square those to get variances. So it'll be 0.32 squared plus all the way up to 0.32 squared. And we're going to do that 5 times. So these are just our rules for expected values and variances. We use them over and over. So notice this 5, so this will be 1 over 5 squared times 5, because we added this 5 times 0.32 squared. Notice one of those 5's will cancel, so we're just back to 0.32 squared over 5, which gives me something when I put in my calculator. I'll let you do that. Now, in your book, you might have also noticed there's a formula for this, because they realize that's going to happen over and over. Your variance is just, for your average, is just equal to your variance divided by n. So in our case, our variance would be 0.32 squared divided by n, which is 5, and we get back to that same thing. So they came up with these shortcuts for averages because they realize you're going to be doing it over and over. And finally, you can find your standard deviation. So the standard deviation for x bar is just equal to the square root of the variance. So 0.32 squared over 5, and this gives you something. Okay, so part B is very similar, except for part B, you're going to be looking for the total. So in this case, we're doing the total of 8 components stacked on top of each other. So now our new variable, which I'll call t for total, is going to be x1 plus x2 plus all the way up to x8. So very much the exact same thing, but we don't have to worry about the dividing by 5 at the end. Some textbooks actually give you a formula for totals, but Ours doesn't. And really, instead of memorizing more formulas, you can just go through the process each time. So the expected value of the total is really just this expected value of x1 plus x2 all the way up to x8, which means just find the expected value of each one individually and add them up. So that'll be 65.9 plus 65.9. We have to do that 8 times. So that gives us 8 times 65.9, which I'll let you put in your calculator to figure that out. Again, you have to do variance before you can do standard deviation. So it'll just be the variance of this x1 plus x2 all the way up to plus x8, which we just add up each variance. Now we don't know the variances, so we'll have to square the standard deviation. So 0.32 squared plus 0.32 squared, and we have to do that 8 times. So that gives us 8 times 0.32 squared. Now you might ask, did we have to do x1 plus x2 plus up to x8? Why couldn't we just do? So why not just the total equals 8 times x? The reason you can't do that is because each component has its own height. They're all supposed to be almost 65.9, but they're off a little bit. So one is going to be 65.8, one will be 65.1, will be 65.9. Each one's a little bit different, so you can't do that. You can only do that multiplication if they're all going to be exactly the same. Because they're all different, you have to actually add each one up, which is why we do it like this. So that's our variance. Now you can do the standard deviation. So the standard deviation for t is just the square root of that. So square root of 8 times 0.32 squared gives you, as the textbook said, square root of 8 times 0.32. If you were wondering how they came up with their answer. And again, put that in your calculator, and there you go.